All right, so you've poured all this effort into building an awesome Java app. It's got features, it's slick, but it's an island. How do you get it to talk to the rest of the world, specifically the world of data? Well, today we're going to build that bridge. Let's dive right in. I mean, really think about this for a second. Your app is over here, running smoothly, and way over there you've got your database. Could be MySQL, could be PostgreSQL, holding all the important stuff. So what's the plan? How do you actually get them to talk to each other? That's the million-dollar question, right? And this is where it gets tricky, because it's not just one database we're talking about. It's a whole universe of them. You've got MySQL, PostgreSQL, Oracle, the list goes on and on. And here's the kicker. Every single one speaks its own language, its own protocol. Imagine having to write completely different custom code for each one. That's not just a headache, it's a full-blown development nightmare. So picture this. Your Java app is standing on the edge of a giant canyon, and on the far side, scattered all over the place, are all those different databases. They can't just yell across the gap, right? The signals would get lost. What we desperately need, is a bridge. A standardized, reliable bridge that lets us send messages back and forth, and it has to work no matter which database we're trying to reach on the other side. Well, luckily for us, that bridge has a name. It's called JDBC. And here's the beautiful part. JDBC isn't just one pre-built bridge to one specific database. No, it's something much more powerful. It's the blueprint. It's the universal set of architectural plans that shows us how to construct a solid, dependable connection from our Java app to pretty much any relational database out there. Okay, so let's get a little more specific. What is JDBC? Officially, it's Java Database Connectivity. But what that really means is it's a standard Java API, or Application Programming Interface. You can think of it like a universal translator. It gives you one standard set of commands, one way of talking. You write your code to talk to the JDBC API, and then JDBC handles the messy work of translating that into the specific dialect that MySQL or Oracle or whatever database understands. It's genius, really. Write once, connect to anything. So how does this whole thing actually work under the hood? It's got a few key players. First up, you've got the DriverManager. This is like the project manager. You tell it, hey, I need to talk to a PostgreSQL database, and it goes and finds the right construction crew for the job. That crew is the JDBC driver, a specialized team that knows the exact language of PostgreSQL. The connection? Well, that's the bridge itself, once it's built. Your SQL query travels across that bridge inside a vehicle called a statement. And when the data comes back from the database, it's delivered to you in another vehicle called a ResultSet. It's a whole little logistics system. All right, enough theory. Theory's great, but it's time to get our hands dirty and actually build something. For our first project, our first bridge, we're going to use something called Apache Derby. Why Derby? Because it's awesome for learning. It's a fully featured database written completely in Java. That means it's super simple, it's lightweight, and it just fits perfectly into the Java world. It's the ideal place to start. Now, one cool thing about Derby is that you can run it in two different ways. First, there's embedded mode. This is wild. The entire database actually runs inside your Java application's JVM. It's super easy for a simple app that's the only thing using the data. But if you try to connect another app to it, you'll get this infamous database has already been booted error. It's a one app only kind of deal. For everything else, you'll want server mode. This runs Derby as a completely separate process, like a traditional database server. That way, multiple apps, multiple users, they can all connect at the same time. No problem. Okay, first things first, we need an address. How does our app know where to even find the database? That's what the connection string is for. It's literally the address. Let's look at this example. See the JDBC/Derby part? That's telling the DriverManager what kind of blueprint to use. Then //localhost:1527, that's the street address and the door number, the computer and the port it's listening on. /mydatabase is the specific office or apartment we're looking for, the database name itself. And that last part, create equals true, that's just a nice little instruction for Derby saying, hey, if this database doesn't exist yet, just go ahead and make it for me. Super handy. All right, we have our bridge and we know the address. Now we need to send a message. This is where the SQL statement comes in. You write your command, select this, insert that, and you wrap it up in a statement object. Think of it as putting your message on the truck that's about to drive across the bridge. And what happens when the database replies? The data comes back in a result set. Now, you can think of a result set like a spreadsheet or a table of data, but with a cursor pointing to just before the first row. To actually read the data, you use a simple while loop. Each time you call rs.next, it moves the cursor to the next row and tells you if there is a next row. As long as it returns true, you can pull the data out of that row. It's a really simple, effective way to walk through all your results. So, congratulations, we've built a bridge. We can send a query, get data back. It works. But, there's a huge difference between a rickety rope bridge that gets you across the canyon and a multi-lane, steel-reinforced superhighway. Now, we're going to talk about how to upgrade our connection from just working to being professional, efficient, and super robust. It's time to level up our game. Back in the day, working with JDBC was a bit tedious. See, every time you opened a connection, a statement, or a result set, you were responsible for closing it manually. You'd have these messy finally blocks trying to make sure everything was shut down in the right order. And if you missed one or if an error popped up unexpectedly, you'd get a resource leak, which is a slow, silent killer for any server application. But thank goodness those days are over. Modern Java introduced a lifesaver called the try with resources statement. It's so much better. You just declare your connection and statement right there inside the parentheses of the try block, and Java itself absolutely guarantees that they will be closed properly when the block is finished. No more finally blocks, no more leaks. It's cleaner, it's safer, and it's just so much easier to read. Honestly, it's a game changer. Now, let's talk about speed. Here's a super important point. Creating a new database connection from scratch is expensive. It's slow. There's a whole network handshake, authentication, session setup. It's a lot of overhead. If your app does this for every single query, it's going to crawl. So what's the pro move? Connection pooling. Instead of building and tearing down a bridge every time, you build a whole bunch of them and keep them ready. Libraries like HikariCP or Apache DBCP are masters at this. They manage a pool of open connections, so when your app needs one, it just grabs one instantly. This is absolutely critical for high-performance applications. Okay, let's bring it all home with a quick rundown of the essential best practices. Think of this as your cheat sheet for writing solid, professional-grade database code. These are the things you should always be thinking about. So, let's run through it. Number 1. Use try with resources. Always. It's the modern, safe way to handle resources. No excuses. 2. Use connection pooling. For any serious application, this is non-negotiable for performance. 3. Do not hard-code your username and password in your code. That's a huge security risk. Put them in external configuration files. 4. Actually handle your SQL exceptions. Don't just ignore them. Log them, understand them, and react to them. And finally, number 5. Optimize your queries. JDBC is just the delivery truck. If your database is slow because of a bad query, your application will be slow too. And there you have it. That's the blueprint. You now understand how to build that critical bridge between your Java application and the entire world of data. You know the challenges, you know the core components, and you've got a checklist of best practices to build something that's not just functional, but powerful, efficient, and secure. So, the blueprint is in your hands. The real question is, what are you going to build with it?